Hello Year 10, this is Mrs. Helms and I want to run you through how to use this SOHCAHTOA magic triangles today. So this is for trigonometry and hopefully you already have a good idea about what trigonometry is talking about. So with trigonometry we need to have an angle and a side or something or other, and we can figure out everything that we need to know in a right angled triangle. So first of all, let's just make sure that we understand the labeling of the triangle. So the longest side is the hypotenuse. And when we talk about the other two sides, we have to have a reference point to talk about. So if our angle that we have or want to find is here, then across from it, so opposite it will be the opposite, and next to it will be the adjacent. So adjacent is another word for next to. Now, if I actually swapped that angle up to the top up here, then the opposite and the adjacent would flip around. So you just need to make sure that you know where your angle is before you can figure out where your opposite and your adjacent is. The hypotenuse is always across from the right angle triangle, the right angle bit, because it is the longest side. So hypotenuse is the longest side. All right, so I'll leave the triangle like that. So hopefully you already have a good idea of the three ratios that we talk about in trigonometry. We've got sine, which we can shorthand it with SIM. That's how it's on your calculator. Cosine, which we just call cos, and tangent, which we just call tan. And each of these have, so two sides can form a ratio to figure out, angles and sides for this. So we use the term SOHCAHTOA to figure out how to solve a triangle. So that is, and we write it out in a magic triangle. S-O-H, SOHCAHTOA. And the reason I write it like this, so we kind of go around, so SOHCAHTOA, is because then I can form a magic triangle around it, which will help me actually solve problems. So this is a magic triangle. You can sometimes see them in science as well. So each of these sort of show you the ratios and how it all works. Now the O and the H and the A all stand for the hypotenuse, the opposite, and the adjacent. And the S, the C, and the T, this stands for sine, this stands for cos, and this stands for tan. So what it's actually telling you that to figure out what sine theta is, we need to have opposite over the hypotenuse. Cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. And instead of making you rearrange these equations every time that you need to figure something out, you can just use this magic triangle to help you do that. So if I'm looking for the opposite and I have the adjacent of a triangle, then I know I'm going to be using the tan ratio. Then I can just rearrange that to say that opposite is equal to adjacent times tan theta. So notice how I put the leaf over the top of that. That's kind of, you would do that with your finger. You're covering what you want to figure out the equation of what you need. So if I'm looking for the hypotenuse and I have the adjacent, then I would be going, well, the hypotenuse is equal to the adjacent divided by the cos angle. So if it's on top, so one on top of the other, that means divide. And if it's next to each other, that means multiply. So you can also do this to figure out the angles. If you have two sides and you're trying to figure out an angle, so say that I have both the opposite and the hypotenuse, and I'm trying to figure out the angle within that, then I would say, well, sine theta, basically what's written here, sine theta is equal to opposite divided by hypotenuse. And then I would go one step further, and to get that angle out, I would go, the angle is equal to sine minus 1 opposite divided by hypotenuse. And in the calculator, that would look like you go shift sine, and it would give you that sine minus 1, and then you would have opposite, say that's 5 divided by 10, and that would give you the angle. So you have to make sure that your calculator is set up properly as well, just to make sure that you're actually getting it in degrees. But this is a really good way of figuring out how to do this without rearranging.